Most moons in our solar system are dead worlds. Cold, gray, silent. They sit frozen in space, covered in ancient craters, barely changing over millions of years. But Jupiter has one moon that breaks every rule. A moon where the ground rises and falls like ocean waves. Where volcanoes blast material so high, they could hit the International Space Station. Where the atmosphere literally freezes and falls to the ground every single night. This is Io, the most volcanically active world in the entire solar system. And it's unlike anything you've ever say Io looks like. Forget what you think a moon should look like. Io doesn't have ice. It doesn't have impact craters. It doesn't sit quietly in the darkness. Instead, its surface is covered in lava, sulfur, and fire. It looks like someone took a giant pizza and splashed it with yellow, red, orange, and black paint. Scientists actually call it the pizza moon because of these colors. And it smells like rotten eggs, because sulfur gases constantly leak from hundreds of volcanoes, while nearby moons like Europa are frozen solid, possibly hiding oceans beneath their ice. Io is the complete opposite. It's constantly exploding. So what makes this moon so violent? The gravitational trap. Jupiter is enormous. More than 1,300 Earths could fit inside it. Because of its massive size, Jupiter has incredibly strong gravity, strong enough to capture 95 known moons that orbit around it. 4 of these moons are special. They're called the Galilean moons, discovered by Galileo in 1610. Io is the closest one to Jupiter, but here's where things get interesting. Io isn't just pulled by Jupiter. 2 other moons, Europa and Ganymede, also tug on it from different directions. This creates a gravitational trap. Io's orbit gets stretched and squeezed. It becomes slightly oval-shaped instead of perfectly round. So as Io moves around Jupiter, the gravitational pull constantly changes. And Io itself, it gets squeezed and released, squeezed and released, over and over and over again. A moon that bends like rubber on Earth. Gravity from the moon causes ocean tides. The water rises and falls predictably. On Io, gravity causes rock tides. Let that sink in for a second. The solid ground on Io, rock and metal, rises and falls by up to 330 feet every single orbit. That's taller than the Statue of Liberty, moving up and down every 42 hours. Imagine standing on Io. The ground beneath your feet would be flexing like a trampoline, except it's made of solid rock. Now imagine bending a paperclip back and forth really fast. What happens? It heats up. The exact same thing happens inside Io, except the heat is so intense that solid rock melts into magma. All that trapped heat has to go somewhere, and it escapes the only way it can, through volcanoes. Volcanoes that reach space. Io has around 400 active volcanoes. 400. To put that in perspective, Earth has about 1,500 active volcanoes total, and most of them barely erupt. On Io, they're erupting all the time. Some volcanoes slowly pour lava across the surface, creating rivers of molten rock that stretch for miles. Others erupt violently, blasting clouds of gas, dust, and debris hundreds of miles into space. If a volcano on Earth erupted like that, the plume would reach the International Space Station. This happens because Io has very low gravity and almost no atmosphere. Nothing slows the explosions down. So when a volcano erupts, material just keeps going up, 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 until gravity finally pulls it back down. And when it falls, it paints the surface. Sulfur rains down like dirty snow, staining everything yellow, red, orange, and black. Because lava constantly covers the surface, impact craters never survive. They get buried almost immediately. That's why Io looks smooth and colorful, not old and cratered like our moon or Mars. It's a surface that never stays the same. Strange mountains and hidden secrets. Even Io's mountains are bizarre. They don't form the way mountains do on Earth through slow tectonic collisions over millions of years. Instead, buried layers of crust crack under pressure and snap upward, like broken tiles popping out of place. The tallest mountain on Io is about 11 miles high. That's twice the height of Mount Everest. For a long time, Scientists believed Io had a global ocean of magma beneath its surface, one giant molten layer powering all those volcanoes. But new data from NASA's Juno spacecraft revealed something surprising. Io doesn't behave like it has one massive magma ocean. Instead, its interior is mostly solid rock with many separate pockets of melted magma scattered throughout. Think of Io not like a balloon filled with lava, but like a sponge soaked with magma in different places. This explains why its volcanoes behave so differently from one another. Each one taps into its own isolated reservoir of heat, a moon that powers a planet, but Io doesn't just affect itself. As it moves through Jupiter's massive magnetic field, electricity builds up inside the moon reaching about 400,000 volts. This electricity flows along invisible magnetic field lines, directly into Jupiter's upper atmosphere. Where it hits, Jupiter lights up with a glowing aurora. Scientists call it Io's footprint. It's like Io is plugged into Jupiter, a moon acting like a battery, powering the planet. At the same time, Io releases about 1 ton of sulfur into space every single second. This sulfur spreads out, creating a glowing ring of charged particles around Jupiter, a plasma torus that you can actually see with the right instruments. Io isn't just a moon, it's a power source. The atmosphere that dies every night. And here's one final mind-bending fact. Io has an atmosphere, sort of. It's incredibly thin, made mostly of sulfur dioxide gas. But when Io passes into Jupiter's shadow, something incredible happens. Sunlight disappears, temperatures plummet, and the atmosphere freezes. Literally, the gas condenses and falls to the surface like frost. For a few hours, Io has almost no atmosphere at all. Then, when sunlight returns, the frozen sulfur warms back up, turns into gas again, and the atmosphere reforms. It's like the moon is holding its breath, and then gasping back to life. Every single day. Why Io matters closing. So why does Io matter? Because it teaches us that tidal heating is messy and uneven. Gravity doesn't heat a moon smoothly, it creates hotspots. This changes how scientists think about life on icy moons like Europa and Enceladus, where heat might be concentrated in just a few places, instead of everywhere. Io may also show us what early Earth looked like, a world of extreme heat and violent volcanism, long before life ever existed. The big takeaway? Io is a world where the ground bends and melts, where mountains snap upward, where volcanoes fire material into space, and where a planet literally plugs into a moon for power. If one small moon can be this extreme, imagine what else is waiting out there in the deep darkness of space. And subscribe my channel for more interesting videos.